Example 12.7, page 606. A sculpture weighing 10,000 newtons rests on a horizontal surface at the top of 6 meters tall vertical pillar. The pillar's cross-sectional area is 0.20 meters square, and it is made of granite with a mass density of 2,700 kilograms meter cube. Find the compressive stress at the cross-section located 3 meters below the top of the pillar and the value of the compressive strain of the top 3 meters segment sa pillar. So, first, pangitaon ang weight sa 3 meter long sa top section of the pillar. The normal force nga nag-act on the cross-section located 3 meters down gikan sa top mao ang sum sa pillar's weight ug sa sculpture's weight. Once nga naa natay normal force, gamiton ang formula tensile stress equals the force acting perpendicularly to the cross-section of the object all over area of the object in order to find the stress. On the other hand, to find the compressive strain, pangitaon ang value sa Young's modulus for granite o i-invert sa expression for Young's modulus formula. Proceed to solution. The volume of the pillar segment with height 3 meters and cross-sectional area, which is 0.20 meters square. So, volume of the pillar times area times height. Substitute, and then we arrive the 0.60 meter cube. Then, the density of granite P equals 2.7 times 10 cube kilograms per meter cube. The mass of the pillar segment is M equals P times V equals the value of P, substitute, and the value of V, which is 0.60 meter cube. So we arrive the 1.60 times 10 to the power of 3 kilograms. And the weight of the pillar segment is WP equals mg equals, substitute the value of m and the value of g, which is 9.80 meter per second square equals 1.568 times 10 to the power of 4 newtons. So the weight of the sculpture is Ws equals 1 times 10 to the power of 4 newton. So the normal force of the cross-sectional surface located 3 meters below the sculpture. So this is the equation. The kaning symbol, this is the force acting perpendicularly to the cross-section of the object equals weight of the pillar plus the weight of the sculpture. So substitute, and then we arrived at 2.568 times 10 to the power of 4 newton. Therefore, the stress equals the force acting perpendicularly to the cross-section of the object all over area equals the value, substitute, and the value of A, substitute, equals 1.284 times 10 to the power of 5 pascals or 128.4 kilopascals. So the Young modulus for granite is Y equals 4.5 times 10 to the power of 10 pascals equals 4.5 times 10 to the power of 7 kilopascals. Therefore, the compressive strain at this position is strain equals stress over Y, the value of stress, which is 128.4 kilopascals all over 4.5 times 10 to the power of 7 kilopascals. So the result is 2.85 times 10 to the power of 6. So we notice nga ang normal force acting on the cross-sectional area sa pillar is not constant along sa iyang length, pero nag-varies from its smallest value sa top padong sa iyang largest value nga naa sa bottom sa pillar. So therefore, the pillar has a uniform cross-sectional area along its length. So ang stress is largest sa iyahang base. Example 12.8, page 608. Stretching a rod. A 2 meters long steel rod has a cross-sectional area of 0.30 cm square. The rod is a part of vertical support that holds a heavy 550 kilograms platform that hangs attached to the rod's lower end. Ignoring the weight of the rod, what is the tensile stress in the rod and the elongation of the rod under the stress? First, we're going to compute the tensile stress in the rod under sa weight of the platform in accordance with the equation. Tensile stress equals the force acting perpendicularly to the cross-section of the object all over the area of the object. Then ato i-invert sa equation sa Young's modulus in order to find the rod's elongation using the original length, which is equivalent to 2 meters. And then gikan sa 12.1, Young's modulus for steel is, which is y equals 2 times 10 to the power of 11 pascals. So we proceed to solution. The force acting perpendicularly to the cross section of the object all over the area. So we substitute the values, and then the result is 1.8 times 10 to the power of 8 pascals. Then the delta L, or the change of length, equals the force acting perpendicularly to the cross section of the object all over the area of the object. Then the original length all over y. 1.8 times 10 to the power of 8 pascals, and then we substitute the original length, which is 2 meters, and then the value of y equals 2 times 10 to the power of 11 pascals. So we manipulate, and then the result is 1.8 times 10 to the power of negative 3 meters equals to 1.8 millimeters. So the tensile stress sa kini nga example is not uniform along the length of the rod. However, kung ang weight sa rod is taken into consideration, ang stress sa rod kay largest sa top o smallest sa bottom of the rod kung asa naka-attach ang equipment. Example 12.9, page 611. Hydraulic press. In a hydraulic press, a 250-liter volume of oil is subjected to a 2,300 psi in pressure increase. If the compressibility of oil is 2 times 10 to the power of negative 5 atm, find the bulk strain and the absolute decrease in the volume of oil when the press is operating. So, this is the small pushing force on a small piston, and this is the object, and then the big press force from a large piston on an object. So we must invert to this formula. K equals L over B equals negative delta V all over the original V all over delta P in order to find the bulk strain. First, we're going to convert the pressure increase gikan sa PSI to ATM. Delta P equals 2,300 PSI equals 2,300 all over 14.7 ATM is equivalent to 160 ATM. Og atong i-identify ang original volume equals 250 liters. So we proceed to solution. Bulk strain equals delta V all over original V equals delta P all over B equals K times delta P. Then substitute the values, and the result is 0.0032. So the value of delta V equals 0.0032, and then the original V equals 0.0032. Since atong i-identify ang the original volume, which is 250 liters, ato siyang i-times ang result. So the result is 0.78 liters. So we notice nga since ang compatibility of the water kay 2.32 times larger than sa oil. Kung ang working substance in the hydraulic press sa kini nga problem were changed to water, the bulk strain as well as ang volume ma-change would be 2.32 times larger. Example 12.10, page 612. An old bookshelf. A cleaning person tries to move a heavy old bookcase on a carpeted floor by pushing tangentially on the surface of the very top shelf. However, the only noticeable effect of this effort is similar to that seen in the figure 12.24, and it disappears when the person stops pushing. The bookcase is 180 centimeters tall and 90 centimeters wide, with 4 30 centimeters deep shelves, all partially loaded with books. The total weight of the bookcase and box is 600 newtons. If the person gives the top shelf a 50 newtons push, that displaces the top shelf horizontally by 15 centimeters relative to the motionless bottom shelf. Find the shear modulus of the bookcase. The only pieces of the relevant information are the physical dimensions of the bookcase, the value of the tangential force, and the displacement this force causes. We identify forces that act parallel to the surface equals 50 newtons, delta x equals 15 centimeters, the initial length 180 centimeters, and the area equals 30 centimeters times 90 centimeters equals 2,700 centimeters square. Then proceed to solutions. The shear modulus equals forces that act parallel to the surface all over area, and then initial length all over delta x. Then substitute the values and manipulate, then the result is 2.222 kilopascals. Then forces that act parallel to the surface all over area equals 50 newtons all over 2,700 centimeters square equals 5 over 27 kilopascals equals 185.2 pascals. Then the delta x all over the initial length equals 15 centimeters all over 180 centimeters equals 1 over 12 equals 0.083. Kung ang person sa kini na example give the shelf a healthy push, it might be happen nga ang induced shear would collapse it to a pile of rubbish tungod kay carpeted man ang floor. Example 15.2, page 751. Determining the equations of motion for a block and a spring. A 2 kilograms block is placed on a frictionless surface. A spring with a force constant of K equals 32 N over M is attached to the block, and the opposite end of the spring is attached to the wall. The spring can be compressed or extended. The equilibrium position is marked as x equals 0 meter. Work is done on the block, pulling it out to x equals positive 0.02 meters. The block is released from the rest and oscillates between x equals positive 0.02 and x equals negative 0.02 meters. The period of the motion is 1.57 seconds. Determine the maximum velocity and maximum acceleration. We find first the angular frequency. Ang phase shift is 0 tungod kay ang block is released from rest at x equals positive 0.02 meters. Once ang angular frequency is nakita na, we can determine the maximum velocity and maximum acceleration. So we proceed to solution. Angular frequency equals 2 times pi all over 1.57 seconds equals 4 s to the power of negative 1. Then the maximum velocity equals amplitude times angular frequency equals 0.02 meters times 4 seconds to the power of negative 1 equals 0.08 meter per second. And then the maximum acceleration equals amplitude times angular frequency square equals 0.02 meters times 4 s to the power of negative 1 equals 0.32 meter per second square. And then x times t equals a times cosine angular frequency times time plus phase shift equals 0.02 meters times cosine 4 s to the power of negative 1 times t. The velocity times time equals negative maximum velocity times sine times angular frequency times time plus phase shift equals negative 0.08 meters per second times sine 4.00 second to the power of negative 1 times t. Then acceleration times time equals negative maximum acceleration times cosine, then angular frequency times time plus phase shift equals negative 0.32 meter per second square times 4 seconds to the power of negative 1 times t. Ang position, ang velocity, and acceleration makita for any time. Ang importante is to remember nga kung mogamit sa mga equations, dapat ang calculator must be on radiance mode.